All right, we're looking at artificial gravity here. So let's go ahead and read our question. One way to create artificial gravity in space station is to spin it. If the cylindrical space station, 275 meters in diameter, we're gonna have to change that to radius, is to spin about a central axis, how many revolutions per minute must it turn so that the outermost points have an acceleration equal to g? They didn't really hint at any of the names of the variables they want me to find or what they were giving me there. But I know that centripetal acceleration or radial acceleration always points radially inward. It's along that radius. And so if I think about which direction gravity acts on me, it's up and down. So if I'm standing on the outside of that space station, I'm going to experience that radial acceleration the same as I would gravitational acceleration. So that's what they're hinting at here, that they want that centripetal acceleration to be 9.8. They're also asking for how many revolutions per minute. How fast do I need to rotate this? So they're asking about rotational velocity or angular speed or whichever word you want to use to describe that term. And there are many. That's why we want to use a rotational variable sheet. Make sure you're using that. All right, so I know I'm going to be using AC is equal to omega squared over R. AC I already know is going to be my 9.8 number, meters per second. The radius, we're going to have to do a little work here. They said it was 275 meters. We got to half that, so that's going to be 137.5. And we're going to go ahead and solve for omega here. And so we find out that angular speed is 0.267 radians per second, but they don't want it in radians per second, they want it in revolutions per minute. So let's make sure we change this. So there's 2 pi radians in 1 revolution. Make sure whenever we divide by 2 pi, we got to put those parentheses on there. That's vitally important here. We want to get rid of seconds, go to minutes. There is 60 seconds in a minute. When we put all that into our calculator, we should get 2.55 RPM, revolutions per minute. Now to put that in perspective, if you lived on said space station and it's spinning like that, you're going to see like sunrise, sunset. You're going to essentially experience 2.5 days every minute because that's how fast that space station has to spin. So you experience a force of gravity, but not a force of gravity. That's why it's called artificial. Okay? Your normal force on you will be the same as if you were standing on the surface of Earth.